All right, I
Hey,
think we're live.
hello.
Hello, hello. Good morning, everyone. We're live and we're going to start straight away. So yeah, good morning and happy Tuesday from us. Welcome to this deep dive by Solita on all things AI, agentic, and autonomous agents and so on. A few practical things before we get into introductions and so on. Many of you have already noticed there's a chat functionality here. There's also a Q&A, which we'll be using, so we'll make sure that there's time in the end for questions and answers, so use the Q&A for that. But yeah, we have many things to get through, so let's get started with introductions and who you have here on stage. My name is Lasse Girs. I'm head of generative AI enablement here at Solita and also run Solita's GenAI studio. And with me, I have Jon and Bao. Jon, do you want to give a brief intro to yourself?
Hey everyone, Jon Tackman. I've been working with data and AI for a long time, and I'm leading the generative AI lab at Solita, and I work a lot with generative models, toolworks, frameworks, agents, and so on.
Good morning, Bao.
Good morning. My name is Bao Tran, and I am an AI architect at GenAI Lab. In Solita, I work on GenAI application, GenAI platform for our customers, but also for our Solitans for internal use.
Awesome. And you'll be hearing mostly from Jon and Bao about all things AI and agents. Before we get to the actual topic, I have to mention another thing. Jon, you and I were on stage at the Solita Summit about a month ago announcing the release of Solita Function AI, our LLM platform. And actually today, Bao, you have announced the release of 2.0 of Function AI. So you've just been shipping over the last few days. How does it feel to have another major release of the platform?
Yeah, it's amazing and a thrilling experience. I mean, we launched it like an hour ago, and this version has so much updates, so much improvement from the last one, and I'm super eager to see everybody, our customer and our Solitans, to start using them.
Excellent. All right, so today we'll talk about all things agents. And just to make sure that we stay on track, I wanted to ask both of you, Jon and Bao, what's the one thing that you would want the audience to remember from this session? And we'll get back to this question in the end when we reflect, but what's the one thing that you would like people to remember? Jon?
I'd say agents aren't magic. Agents are really well-structured dialogues with LLMs. So instead of just chatting with an AI and having it return the first possible result it can think of, you kind of structure that around tools and templates, and that's how it works. And then you pass along the stuff, and it looks a lot more complex than it really is. So I want people to take away that it's not magic. It's completely engineered.
And Bao, what about you?
Well, I think this is a bit cliche, but I think every AI application should start with a business values. From a technical perspective and what we're going to go through today, you would see that it's very feasible to build AI applications and platform, but it should all start with business impact and the real usage for our end customer.
Excellent. This sounds very pragmatic. In other words, we'll focus on making sure that we create value, and there's no magic involved. It's just structuring of how we solve a problem. So very pragmatic. So in today's agenda, we'll first go through some basic terminology and concepts around AI agents and agentic behavior. We'll give some practical examples around it. We'll also clarify what MCP or Model Context Protocol is all about. And then we'll recap, reflect a little bit, and then, as I mentioned, we'll look at the Q&A towards the end of the session. And we're aiming to close by 15 minutes to the hour. So let's start with some of the basic terminology. Everyone, maybe 2 years ago or 1 year ago, everyone talked about the chat interfaces and LLMs, from chat GPTs to copilots and so on. Now this year, especially the second half of this year, everyone talks about agents or agentic. Jon, what does it mean? What's the difference between an agent and a chat interface, and what are the characteristics of agentic behavior? Like, what do we actually mean by this term?
Right. So as a user, it's kind of tricky to tell apart the two from time to time, because very often that is the user interface that you have is the chat, and it's the way that the AI responds that actually hides the agentic functionalities behind it. Of course, that's just when you talk about graphical like chat user interfaces. It can also be something hidden a little bit more deep inside the system. But if you think about how ChatGPT reacts if you just talk to the model, it reasons around your question, and then it just responds however well it can. Whereas if you run an agent in the background, it will take your request and it will parse it, and it will go through what you call an agentic loop, basically, and then return a result to you, or do actions, or search for things, or do other stuff in the background. So it's not just a direct response, it actually executes tools and then goes on. In M365, for example, you have multiple versions of this. So you can have both the kind of chat tools, which are basically then grounded on the tool itself. So you have, for example, Copilot in Excel. It'll respond to you to questions just about how to use Excel. So it's grounded in that, but it's not an agent. It doesn't actually do things for you, and sometimes painfully, obviously. But that's basically how you differentiate between a chat AI and an agent, is that the agent actually does things for you.
Right, and we'll get to, you mentioned the agentic loop, so we'll get to that in just a second and define some key features of agentic behavior. But Bao, anything that you want to add to just clarifying the difference, I guess, between chat and agentic?
Yeah, I would say that the chat's not able to plan and to think and to reflect on its own, or tool calling. But the agents can do. And maybe one thing to emphasize that the chat, as it implies, you need to ask something for the agents to do it. But for the agent, it can be even headless or UI-less. So everything just happen in the background without you have to intervene too much.
Right. So let's talk about this more in detail. I think for me personally, the reason I earlier this year also stated that this should be the year of agentic, because the whole thing with chat is we do a lot of copy pasting from one application to another, and the big difference here and the impact of agents is that now they actually do the work for us. So they perform actions, or they perform tasks. But it's a little bit more than that. And I remember, Jon, when you were presenting in some months ago in our team meeting, you talked about the other features of agenting, and especially the idea of reflection. So yeah, can you talk about the agentic loop as we mentioned earlier? What is it really? What does it do?
Yeah, sure. Let's take a look at this picture. So I wrote up a few ideas about how you could think about this, and basically an agent passes along the information that it gets through different stages, and the reason why you do this is because it's a bad idea usually to ask an AI about something and then keep the same conversation going, and then asking it, well, how do you think that answer was? Like, was that a good answer to my question? And then it's like, yeah, that was a really good answer. I gave you the best answer ever. I'm the bestest answerer of all questions, and so on. And so you need to kind of have a bit of LLM psychology going on there. So what you usually do in an agentic function in a generic loop, you basically pass the query first to a planner, and then you ask the planner to figure out, what do I need to do to fulfill this user requirement? Is it a search request, or is it a file retrieval request, or is it something else? And then basically ask the first model to evaluate and create a plan for this particular task. And then when you have that plan, you pass it to another agent, which is then tasked to, okay, this is the user's original query, and here is the plan on how we're going to do this. Now you do all of these steps, please. And then it runs through all of those steps and executes the plan. It then also, if you don't separate it into a separate step, it also synthesizes an answer for the user. And then I could call that kind of an answer candidate. And then you give the answer candidate and the query to a reflection agent, who then, or a reflection process, who then basically makes an evaluation or a scoring on like how good was this answer in relation to the query originally, and does it answer all of the questions? Did we miss something, for example, in the middle of a question, or was there a side note that actually should change the answer? Or if it was another kind of a task, does it pass tests or something like this? And then you come to a decision point where you either decide to, okay, this is a good enough answer, so I can pass this back to the user, or if it's not, then you basically constructively critique the answer, and then you pass it back to the planner again. Hey, listen, planner, we did this thing you planned, but this came out. So could you please reiterate this plan? And then you run it through again. And of course, that might end up in an infinite loop if it's a really hard task, or the information that's requested doesn't exist, or something else happens. So you have to have kind of like a max iterations loop on that. So then if enough time has passed, then you just return to the user and say, sorry, based on this information, I can't answer that task, or I can't create that because X, Y, and Z.
Excellent. So it's not just about performing tasks, and it's also not just about creating a plan to perform the task, but there's that element of reflection, and you described or also mentioned like the scoring, which can then create this loop. So how does this work if I want to create a workflow that has multiple agents performing various different tasks? How do I make it work either in like one linear flow, or maybe them working in parallel, just in high level principle?
Yeah, so we talk a lot about context. And context is basically the window of text or materials that are passed to the LLM when you ask it a question. In a normal flow, it's the history of the conversation, the next question, and then you ask the LLM to fill out the next one. So context is basically the LLM's memory. That is what it remembers. So when you pass these along, you need to basically, then the plan is one memory, and the answer candidate is one memory, and the query is one memory, and you pass those on towards the agents that do need them. And if you pass along memory and instructions, you can delegate tasks basically. So you can ask one agent to delegate the task to another agent. Say, for example, you want the implementation agent to be more exact, then you tell it that before you release this task, you need to ask this testing agent to test your response, that it fulfills specific criteria. Say, for example, safety guidelines or some Python code tests or something else. So you need to kind of then let the agent have the information it needs to have in order to do what it needs to do. So it's memory for the agent or instructions, if you think, but it's basically a context window.
Excellent. And we'll get to a practical example in just a second, but Bao, I wanted to ask you as an architect, just high-level principles of how do you architect or design a solution for the context or the memory? How do you make sure that the various agents have access to that context and memory?
Yeah, so as John said, when we use agents application or system, they work on a very long horizon amounts of tasks, and these generates a lot of information and context. So it's very essential to managing these, and there are a couple of strategies or approaches that one can use. One is using the sub-agents like John mentioned, but also you can consider using persistent memory. So in this case, it means that the agent, when it do something, then it have a external place where it writes down what it have done, what was the plans, and so on. So this can be, let's say, a markdown file. So this markdown file can be given to another agent, or the agent itself can pick it up later to start continuing working on them. So by doing this, we limit the amount of information we have in the context window while still keeping all of the relevant information available for the agents. And then another way to tackle this is to do compactions, which means that you feed what you have generated into some sort of summarizations agents, and they can compress this into only very essentials and important informations, or they can also discard some unnecessary information as well. So by doing this, we narrow down the amount of information that we have in the context window. So all of these three approaches are really relevant. You can use one of them, or you can combine them together to make the agents working the better and have the longer ability to work on a longer task.
Excellent. And we'll get to a practical example now. I do want to mention we have some questions already in the Q&A, so keep that going. I'll keep an eye on those as we have the conversation, but in general, we'll try to address some of those towards the end. So let's get to an example. I do want to mention from Bao how you described it. I guess one of the main benefits from having AI agents perform some of the work is that they don't mind documentation. They don't mind creating tediously creating documentation, which we know is one of the tasks that we as humans don't generally like to do in development work. So this is one of the benefits. But let's get to an example. We have created a simple scenario, which I'll let you, Bao, talk through, of how you can use an agentic solution in real life. So yeah, Bao, do you want to talk through this example that we got here?
Absolutely. So we were thinking to how to make this super concrete and practical for everybody. So what we came up is sales, right? Because everybody have sales. And so let's imagine that you have a customer demo request. This can come from your customer website form, can come from email or phone. So typically what happened nowadays without agent is that somebody would check those requests. They need to research on the customers, what are their industry, what are the products that they are interested in, and so on. And also find the suitable reference cases that your company have to present to the customers. Then the sales prep representative might also coordinate with technical teams to setting up the environment for the demo, sending messages to them on Teams or on Slack, and schedule a meeting with customers. So as you see, there's a lot of system and channels involved in this relatively simple workflow, from CRM, email, calendar, etc. And there's many people involved as well, jumping around to get this work. But with agents, what this can happen is that the agent would automatically pick up the sale case from the CRM. It then go to do some customer research. And this can be online or on some reference banks about customers. And then it search internal document system for suitable reference cases as well. Then the agents inform all the stakeholders about the new leads and all of the relevant information. Request technical teams to prepare demo, schedule meeting with everybody from sales, from technical team, customer service, so that everybody can think before having the meeting with the customer, and finally reply the customer request and having the demo sessions. So all of this can happen simultaneously or step by step only by using the AI agent. So it would do all of that, reflecting, planning, and then validating that everything has been injected and done. So as you can imagine, this have a lot of connections between the AI agents with the external tools as well. So that's when we would go to the next part, which is model context protocol.
Yep. And before we get there, just to sort of summarize, so you've gone through an example here where we have different types of tasks that we're letting agents perform. So there's meeting scheduling, there's internet searching. This one doesn't have, for instance, writing code, but that could be another one that it creates a text or code output, or maybe creates some other types of output. So there's many different tasks that these agents can perform as instructed. Now, there was also a question in the Q&A about how to select the right use case in an enterprise environment where you have multiple, maybe bigger or legacy systems. And in this case, you've described how the agents interact with CRMs, etc. So let's get into how that actually works. How can agents perform tasks in these systems that are typically enterprise systems? And that brings us to the concept of Model Context Protocol, or MCP. It's almost a year ago since Anthropic released this standard, this open standard they call the Model Context Protocol, which is, or MCP, which is a way for LLM-based solutions to communicate with or perform tasks in source systems in a safe and scalable way. Let's talk through MCPs. What are they and how do they actually work?
Yeah, so MCP is as mentioned, Model Context Protocol, and as we mentioned earlier about the context management, that's one of those central key things to making LLMs work. And I've written about this before as well, that if you have a really good context, you can actually make do with a much smaller model than you could otherwise. So if you have the best and brightest model that costs the most to run, but you don't give it enough context, then you won't get good answers. You might actually get hallucinations. But then if you have a well thought out context, a well thought out payload for the LLM to perform its task, you can do with a lot smaller model. And that's kind of where MCPs come in as well, because MCP packages traditional API layers. So traditionally, when you want to integrate systems with each other, you need to tell them exactly, okay, this is the code you need to run in order to get that data from this system to that system. And this is kind of heavy, because that means that if you have multiple of these, then the code becomes longer and longer and longer. And if you need to tell the AI that if you need this data, then you need to run this code. If you need this data, then you need to run this code. Then it becomes longer and longer, and the context becomes cluttered. And there's a lot of research on how a cluttered context degrades the model performance. So MCPs basically package those integrations into much more understandable natural language descriptions. So there's a description for each of the MCP servers. Like, this MCP server can help you if you need to do A, B, or C. And then you just need to ask it to do so. And to do so, you have this tool, which is named so-and-so. And then the LLM knows, okay, if I need to create a document or do something else, then I run this tool on that server and it will do it for me. I don't need to know the code. And that's basically how you obfuscate the actual code implementation from the LLM model, so that it can still operate it without having to give all of that context to begin with. Right, I got off on a tangent there. What was I actually supposed to answer?
Basics of MCP.
Yeah. So yeah, you basically package sources in servers, and then you have the software or the agent that you are running implements what we call a client. So you, instead of having a direct API call to the source, you actually have a client server connection in between, which then supports all of the standard client server thingamajigs like caches and remembrance, everything else, reconnections, and that helps a lot with the complexity of those connections. So everybody's been saying like, okay, MCPs are the USB-C for AI. Now, USB-C is not a good analogy in my opinion, because USB-Cs get like loose and then they don't really work that well. And MCPs are really, really good at plug and play. It works really nicely. There are limitations, of course. You can't put too many of them into it. And there were some cases of bad publicity for MCP as well, because it's a starting thing. We've been doing it only for a year, which is in software world very short time. So it's still maturing, but we've had good strides on that recently. It's for example, authorization and authentication has become available directly on the protocol, which helps a lot that you don't have to do it externally as well.
Excellent.
Yeah, John mentioned about the USB-C, and I usually use my metaphor is the HTTPS, or the similarity here, that you can use any browser like Chrome, Safari, Firefox, if you're still using that, to access any website. So that's the same for MCP and AI agents or LLM. So when you use MCP, any models can also understand the tools, the resource that you are able to give through the MCP server. So as you see here on our slides, we have a workflow of how it would work with MCP typically. So when the AI applications connect with the MCP server using the MCP clients, then first of all, the MCP server would expose its available tools and resources. So it would say to the AI that, hey, I have these tools. You can use it to schedule a meeting or to create a task, or you can use it to access these files and folders. The AI agents knows that and keep it in mind. So when the user asks a prompt, let's do this something for me, schedule or book a train for the next week business trip, without even mention what business trip it is, the AI already know all of these available tools and resources, would be able to call them. First of all, let's say to calendar to check what business trip you have next week, what time is it? And then it's also have availability into the tool that book the train tickets. And so it sends all of the time, destination, origin that it found from your calendar and send to the booking tools. And after that, it would compile everything together to make a final result. And then it sends back to you as a user, hey, I have done everything. The train ticket is here. So that's how AI agents would work with MCP servers.
Let's just circle back to our example case where now we make this even more practical from the CRM example that Bao you mentioned earlier. This is the MCP servers and clients in action in that example.
Yeah. So if we think about the example with MCP in place now, the sales lead AI agents would have connections with your CRM, can be HubSpot, Salesforce, etc., whatever, and also task management, document system, messaging, and email. So you would have MCP server connects to each of the tools and source system. So when the AI agents notice that there's a new case in your CRM, it will start planning and start calling these tools to create the sale, check the sale case for detail about the customer, create tasks for everybody, search its references from your reference bank or from the internet for customer information, then compile everything and send an update to everybody who's involved. Can be sales, can be technical team, and also helping you in draft a reply to the customer and book a meeting as well, based on everybody's calendars. So all of these happen within seconds instead of maybe a few hours of people working on all of these tasks. And with AI agents and MCP server, this works seamlessly between across systems. And yeah, so quite simple, I guess.
And Jon earlier already talked a little bit about the maturity of the protocol. We're talking about something that is almost a year old. Bao, in your experience, what are some of the potential pitfalls or risks associated with the protocol, with MCP, given its its immaturity at this point?
Yeah, so like Jon mentioned, there's a considerable risk in security. So when you connect AI agents with your external tools and source system through MCP, you basically giving them the access to perform actions and retrieve data from your tools and data sources. So the first of all thing is that always have risk assessment in place, security assessment before taking any external MCP server in use, because that could pose a lot of risk onto your system. And I would also mention again what Jon said about limiting how many MCP server that the AI agent have access to at the same time. So in terms of scalability and AI agent system design in general, I would say that the agents should have their own task or purpose as its definition, right? So it should also have access to only those tools or MCP server that are relatable or relevant to its purpose and not something else.
Yeah, it's very important to keep in mind that context management is that the LLM doesn't understand anything outside of what you've told it about the context, but it also understands everything about the context you give it. Well, not understand. I mean, I don't want to imply it that it really understands it, but as long as you've mentioned something to an LLM, it does keep it in mind. So if you give it extraneous tools or access to systems that it doesn't need, you might get unintended consequences on especially edge cases where people ask it to do things that weren't perhaps designed. A good example would, for example, be a file system search or something else when the agent doesn't actually need extra files. It has already the access to the user and to the system it's supposed to be working with. But then if it also has file access, then you might end up at a situation where the agent, for example, writes things to file that it shouldn't be writing, and it stores it in a place where that data shouldn't exist. So you might end up with a case of your CRM data in your SharePoint, for example, and then that's not something you want to have. So you always need to think through those cases really carefully. There was earlier actually a question that relates to this a little bit. There was a question about how to make sure that AI hallucinations don't break the kind of agentic cycle. So what if the iterations, you've told it that it's 3, but if it starts hallucinating and being really workaholic, and it says, well, I'm going to go on until this is done because it's really important, and then it just keeps going. So the answer there is, of course, that with agents, it's 90% software development, 10% AI. So you do deterministic code for retry loops and so on. That's what you call then the scaffolding or the framework of the agent. So you have to make sure that that's well built and well secured. using the correct permissions, using the right libraries and up-to-date software and so on. So it's kind of the problem. If you wipe through it, then you might get that problem.
It's a really important point. I did want to get back to that one. So when we've now described an agentic system, this is by no means just prompting a chat who then creates it. This is actually software engineering or platform engineering, whatever you want to call it, or software development that builds the whole system. It is just using the LLMs, but it is a much wider system. And I do also want to mention, from how you both, Bao and Jan, describe MCPs, although the name talks about model context and managing the context window, but actually a really important part of MCP, of the protocol, is enabling the use of tools, which means access management. It means privileges and a whole bunch of other things that maybe the name wouldn't suggest, and maybe originally wasn't what everyone talked about, because we talked about managing context, but actually it does a whole bunch of other things than just memory management. But
yeah, the original was probably running a search to get the context that you need to answer the question, like what's the weather in Helsinki. The model doesn't know, so it needs to fetch it. So you have context protocol.
So let's start wrapping up. There's a lot of questions in the Q&A. We did cover a few of those, but before we get to those, I wanted to get your thoughts, both of your thoughts on just, now we've talked about how we designed this. So we talked about the agentic loop, about MCPs more in detail, but still, just what are some guiding principles that people should bear in mind or keep in mind when designing an agentic system?
We covered a few of these already, but definitely, like the value is I think the most important. Don't put AI in places where you don't need AI. If there is a process or a good way to do things, that you don't need to necessarily AI it. Don't slap an AI chat in everything you want. It's kind of not that the value is not there. So you need to figure out, like, where is the actual value of that task. If you can justify the cost of running an LLM against it, then good, that's a good case. The other is security and infosec implications. We already covered a few of those, but you need to be really careful about this, because it's kind of new territory in some sense. So you need to do the risk assessment that Bao mentioned. You need to do proper infosec evaluations as well. With the ethics and doing the right thing, this is something that I'm really passionate about. So the EU AI Act provides many tools to evaluate this, but I think it's really important for us to think, as sounds grandiose, but as a species, not to run AI against everything we can think of just because. There is value to be had, but there is also so much unnecessary fluff to be had, and I want to avoid AI slop, basically. So that's another thing that can even happen within the enterprise if you generate too much things and then store them, and you end up with a situation where the signal to noise ratio is just horrific, and that's something that you need to keep in mind as well. And it's a thing. Yeah.
Wow, anything you want to add?
Yeah, I think John have mentioned most of the things already. I would just say, from the AI architect perspective, I think 90% of developed AI agents are software development, like John said. So all of the software development principles are still applied. You should have testing, you should have CI/CD pipelines in place. You should have good infrastructure if you're running on cloud, for example. So all of that still applies. There is no shortcuts in AI applications development as well. So when doing or putting them into production, then you should keep in mind of that as well.
Excellent. And before we get to the Q&A, let's do our own reflection. So we said in the agentic loop, they do reflections, but let's do our own reflection. In the beginning, I asked you, what's the one thing that you want people to take away from this? Jan, you mentioned that it's there's no magic involved. Do you think that we've been able to
I think that's
goal?
pretty clear from the 90-10 analogy, for example. It's all design. It's not magic.
And Bao, did we achieve your objective, or do you think that you've achieved your objective?
I think so. I think through this session, we have been able to show the audience that there's a lot of possibility with AI agents, right? You can connect to this and that tools and source systems and so on. So the world's your oyster, but always going back to business and impact and real values before implementing any AI application or agentic application.
Excellent. So just a summary, we started with clarifying some key terminology or basic terminology in this space, because there's so much talk about agentic at the moment. We talked about the agentic loop and some unique features of agentic, which is not only performing tasks, but the fact these are planned, then they're performed, and then there's a reflection which creates a loop. And that's the unique feature of the agentic solutions or autonomous agent systems. Through an example, we've highlighted how this works. We talked about the MCP or Model Context Protocol, and then talked about our guiding principles for making this real. So let's get to the Q&A. And by the way, I know we've got about 4 minutes left. Now, the three of us are probably going to stay here. We might run over with the Q&A. So if any of you are able to stay on for longer, then stay for the Q&A. If it runs over, the system is going to keep running as long as we talk. So we might go over, but we'll try to cover some of the important Q&As first. As a way of closing, also want to mention you can connect with us on LinkedIn. Some of our details are there. You can book a meeting if you want to talk more with us at Solita about making this work. And you can also visit our landing page where we've collected everything we have when it comes to AI. So it's Solita.fi/AI. It's our landing page. So those are the three things that you can do right after this in case you want to talk with us further. But let's get to the Q&A. Jan, I know there's one or two questions that you want to tackle. Yeah. I didn't see yet which one it is, or which ones do you want to cover?
I took a look at these Q&A things, and there's one here from Lars Hellström, which is two parts actually. There was a workflow analysis core to agentic AI. Any experience on how to use agents itself to analyze workflows, so-called self-improvements? And is there a benefit to multiple reflection rounds, and when to give up? So you've hit a pretty core issue that I'm working on right now, for example. So self-reflection is very important in this space, and many times it's very difficult for a person to figure out how to do this. So many have probably heard about prompt engineering and AI prompt engineering in the past year, and basically AI has a lot of bias, and you can actually use that to your advantage. So if you ask the AI to design you a prompt that does a specific thing, then you feed it back the result and keep doing this in such a way that it can itself figure out how to improve the prompt or the system, then that kind of improves it. And that goes for workflows as well. So you can persist memories or you can persist context, good and bad solutions and things like this inside the code. Well, not inside the code, but inside the context, which the code manages, of course. And then also have that kind of improve the situation. But it does require management all the time. You need to have the human in the loop evaluating, like, is it becoming better or not? You need to figure out what the metrics are. And as Bao said about the value, you need to figure out what the value is for the agent. So the value is what drives how you measure it, how it's becoming better. And that's also a key thing here. So you do really need to understand why you're doing it, how it can be measured, and what the solution patterns are in order to make them better over time. And about the multiple reflection rounds, that's precisely it. So if you give the agents you give them permission to fail, so then you can learn why they failed, and you can insert that into their own context, which means they won't do it again. So that basically is why multiple rounds usually do yield benefits, and about the self-improving workflow as well.
Thanks. And so now, being aware of time, I want to thank those of you that stayed on and need to leave now. The three of us will stay on answering some more questions, but thanks to everyone who tuned in and need to drop off for their next thing. But we'll stay on and answer a few more questions.
Thanks, everyone.
Thank you.
Bao, I wanted to send this one to you. That was I think it's a simpler question about the difference between function calling and LLM and then MCP. To cover the basics of that one.
So function calling, MCP and what?
So the difference between MCP and function calling of an LLM.
Oh yeah, so
it's a trick question.
Yes,
it is. So the MCP, it is a common language that wraps around the external tools and source system that one have, and then it exposed to the AI through the MCP. And so you need a client in place for getting and interacting with those MCP server, and then then the AI or the LLM would be able to pick up these when necessary and when relevant. The tool calling are usually built within the AI application itself, or if you're using these ChatGPT and so on, then they are in the background of those. And so it would be called automatically by those models. So with MCP, it's more scalable, and you are able to use that with any models that supports MCP and connects that with any agents if you want to.
Yeah, and then a little bit about the kind of trick question there is that basically function calling or tool calling in an LLM is tool calling in an LLM. The MCP servers are tool calls as well. So we're kind of tricking the system into understanding concepts that are more complex than they really seem. So it's just a tool which you call like this, and it does this, but it's hidden within the protocol in the sense that you get the tools when you ask for them. You don't get them all before you start. So it's a little bit about they're the same thing, but it's much more nicely packaged.
All right, let's do one more. I think at least if this one is a little bit higher level, but there was some questions about what are good use cases. If I really simplify, like what's a good use case? So if we think of like technical feasibility in this case, how do you select the first case to begin with? I would assume based on how much we talked about MCP, then availability of MCP server and client would obviously be one of them. What other factors can you think of that would increase success rate or likelihood of an agentic system when you select use cases?
I think that we need to answer that question. You don't really need to think that much about do we have an MCP or not, but it's more about what is it that you're actually trying to do. So if you have a well thought out sample task, for example, that takes a lot of time for you, or something that reduces the quality of enterprise data, or something that doesn't work in the process that keeps failing and needs some help or something else, then that would be a place where you could take a look at do I have any kind of tools that the LLM could run that would help this situation. So say, for example, that it's a data entry issue, for example, that specific sources don't produce enough metadata, for example, for when you insert them into the system, then you might want to put an agent in between that gets that metadata and verifies the availability of the correct info and then puts it in. So it can be something really, really simple. It really doesn't need to be something complex. The simple ones are usually the ones that yield the most benefit, that you can use the smallest models for, and which are simplest to do as well. many times when I've talked about this, that the one thing that comes up is research. So I want to have an agent that does all of this research for me, for example, fetches a bunch of web pages and summarizes everything. And it's really bloody hard to do. It's very, very difficult to get an AI system to be very exact in these kind of tasks. And you run into a lot of risks in the sense of bias and then completeness and everything else. And you need to measure these as well. So whenever you deploy an agentic task to any kind of enterprise system, you need to have those metrics in place as well about how is this supposed to work and does it actually do it now? Do you have the expected results on it? There was actually a question here that I thought we could take still about how to validate and secure agentic systems using multiple MCP servers. And any good guidance available? Nope. That's one of those things where there is no magic bullet for that one. That's you really need to do extensive work if you start doing that. So if we go back to function AI that we developed, for example, so there we decided, for example, when we know that we will have many MCP servers serving that system, we created what we call an MCP garden, basically. So we made a walled garden for those MCPs. So the users cannot add any MCPs they want. If you want to create an MCP within the enterprise to be accessed through that system, you also need to go through an approval process, and then you are put into the garden, which is then templated and well secured and everything else. So that's one of those things that you need to think about is that the USB-C compatibility of MCP also is a risk. So if you are able to connect whatever, whenever, it's a risk. So you need to manage that somehow. And the MCP standard itself is so simple that if you read through the SDK kit, you can quite easily write your own server and your own client for just about anything. So there's another kind of risk hidden in that as well.
I was actually going to pick that question too. So
yeah,
we have the same thoughts. I would though correct your first response, which is that you said, no, we don't have good guidance available. I think you just provided good guidance by saying
we don't have a magic bullet.
There's no silver bullet, exactly.
Yeah.
There are good software development principles around designing secure systems.
And we've thought a lot about this, so yeah.
All right, I think with that, we're gonna close the session today. We'll go through the Q&A, and if there are some questions that we want to get back to, then we might do that through blogs or newsletters or something else. But yeah, just as a reminder, you can connect with us on LinkedIn. There's a book a meeting, and there's a book a meeting functionality here in this platform, and our landing page is also sent. I think some of the emails have also covered our Ways of Tech report, which is definitely worth a read. But with that, thanks for staying with us this morning. Have a great rest of week and November, and eventually we'll get to the holiday period too. But yeah, thank you, Bao. Thank you, Jan, for insightful conversation, I should say. Thanks all.
Thanks everyone.
Thanks for joining.
And thanks, Nino.